Welcome back, everybody. Our next installment of quadratic functions and their graphs talks about the characteristics of their graphs. So we're going to start with the axis of symmetry and what that means. If we make a XY table from -3 to 3 of the parent function, remember, the parent function for quadratic is x squared. So we're plugging each of these x values into that xy table. -3 squared is +9. -2 squared is +4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. If we notice, on either side of 0, the values are repeating exactly in the y. We have 1, 4, and 9, and 1, 4, and 9 on the bottom. So they're repeating on either side of the vertex, which for the parent function is at the origin. This is because parabolas are symmetric. Remember, symmetry means that we can draw a line through our graph or our figure of a square or rectangle, and we can fold it evenly onto itself. And this is the case on a parabola as well. This line that we can draw is called our axis of symmetry. It has an equation of x equals h, and h is the x value of our vertex. If we know where the vertex is and a few points on either the left or the right, then we can draw the rest of the parabola by mirroring the points. So let's try a few. Let's take a look at example 1. First, let's talk about our transformations that are happening. This negative, remember, reflects over x axis. The 2 is a stretch. The +3 is left 3 because our x's are liars. And the +4 is up 4. We also know from our last lesson that the left 3 up 4 means that our vertex is at -3, +4. So if I want to do an XY table to graph this, if I'm not using a graphing calculator, then I'm going to have -3, 4 be in the middle. And maybe I'll pick a -2 and a -4 to plug in for x. When I plug in -2, I get a 2. When I plug in -4, I should also get a +2. Remember also that we're talking about our axis of symmetry here. So we're looking for where that might be. Let's sketch this graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -5, +5. So our vertex is at -3, 4. We know we have a point here at -2, 2 and -4, 2. And we know that our parabola should be facing down because of the reflection over the x-axis. So here's a sketch of our graph. Now our axis of symmetry, or that line that we can draw straight through the vertex, is at x equals -3. Because if we know this, then we know our AOS, our axis of symmetry. And then we're going to include that axis of symmetry on our graph now. Let's try number 2. So if I'm looking at number 2, this right here is a shrink of 1/2. This goes right 4 and down 2. That means our vertex is at 4, -2. And this vertex of 4 also tells us that our axis of symmetry is at x equals +4. So we can again use an XY table if we're not using our graphing calculator. We are using our graphing calculator, then we want to plug in this equation and go to the table and find our 4, -2. Maybe use the 3 and the 5 on either side to get the other points that we're plotting, which I believe are going to be -1.5 for either of those. So sketching my graph, I'm going to put my vertex at 4, -2, plot those 2 other points, and there's my parabola. And then my axis of symmetry at either one of those at x equals 4. Make sure you label that axis of symmetry. All right, standard quadratic form. Standard quadratic form is our ax squared plus bx plus c. That's a form that we use when we plug it into quadratic formula. In this form, we're not really sure where the vertex is because it's not indicated. So we need to use an equation. The first equation we're going to use is x equals -b over 2a. That finds our h part of our hk. And then to find the k part, we're going to plug that value into x, and the resulting value is our k, or our y value. The a in the standard form equation is still the reflection, stretch, or shrink. And in this case, the c is the y-intercept. The axis of symmetry is still the x value of our vertex, but in this case, it'll be found when we find x equals -b over 2a. All right, example 1. We have a, b, c. Standard form equation. So we start with x equals negative. That negative is part of the formula. And then our b is a -6 over 2 times a, which is 3. A -6 is a +6. 2 times 3 is +6. And 6 over 6 is 1. So the x value of our vertex is 1. And our axis of symmetry is at x equals 1. Now to find that y value, I'm going to take my 1 that I found for x, and I'm going to plug it in for this x and this x in that equation. So we have 3 times 1 squared minus 6 times 1 plus 1. Make sure you're following your order of operations. We do the 1 squared first, which is 1. And then 3 times 1 is 3. Minus 6 times 1 is 6. Plus 1. 3 minus 6 is negative 3, plus 1 is negative 2. So the y value of our vertex is at negative 2. Our axis of symmetry is at x equals 1. Let's try example 2. A is 1/2, B is negative 4, and C is negative 2. So x equals negative b, which is negative 4 over 2 times a, which is 0.5. The negative 4 on the top comes positive 4, and 2 times 1/2, or 0.5, is 1. 4 over 1 is 4. So our vertex starts at 4, and our axis of symmetry is at x equals 4. We are then going to plug that 4 in for both of our x's in this equation. So we have 0.5 times 4 squared minus 4 times 4 minus 2. First, we're doing the 4 squared, which is 16, and 0.5, or 1/2 of 16, is 8. Minus 4 times 4 is 16, minus 2. 8 minus 16 is negative 8. Minus 2 is negative 10. So we have a vertex at 4, negative 10. And then we can go from there. We are going to work on these closure problems in class to start tomorrow. This is the end of part 1 of your notes for section 2.2. Have a great day.